All right, so check this out. Here's what we're going to be working on. Negative x squared plus 2. I asked you what you did it, and Rainey said it's going to flip upside down and move it up 2. Let's see if that's the case. I'm going to put negative x squared plus 2. What Rainey is thinking is that this plus 2 over here is going to move the graph up 2. This negative over here is going to flip him upside down. Are we cool with this? Is that what, am I accurate to say that, Rainey? Is that what your thought process is? All right, let's see what this does. There we go. Look at that. What it did was it pushed the graph up 2 units. And it also flipped him upside down. It reflected him upside down. I agree with you completely. Does this make sense to you? Yes, no, it does make sense, it doesn't make sense. What's your thoughts? Come on. All right. I need you guys to respond back to me quickly. And I know I get overwhelmed and whatever. I don't mind you guys responding back to me because at least I know the audio is still working. All right. All right, now, let's try this one. This 2x squared. What is that going to do? What do you think that's going to do? And this might not be as intuitive. In fact, I might even just have a discussion with you with one. If you don't know, say IDK, and at least I know that you're alive and you can hear me. All right. I want to graph 2x squared. And what we've been doing is we've been kind of analyzing the way these graphs look without even having to make a table or anything. We just kind of graph it. All right? Now, the 2 in front of the x squared term, here's the way I think of it. You guys ever eat gummy bears? Okay. You eat gummy bears? Now, what's the correct way to eat gummy bears? I'll be honest with you, I'll tell you, and I know you do this. You gotta admit, you do this, right? You take the gummy bear. In fact, I actually might have some gummy bears in the refrigerator downstairs. No. You don't shove it in your mouth. You torture the gummy bears, right? Like, you take a gummy bear, and then you take the head and pinch it in your fingers, and you take the feet and pinch it in your fingers and say, "No, don't torture me!" And then you pull the head up, and you pull the feet down, and it stretches him out, right? Like, come on. You know you do it. I do it too. That's how you eat gummy bears, right? You stretch them. You put them in like the torture chamber, and then you're like basically stretching them until they basically break apart, and then you eat the head or the foot, the body or whatever. I don't care, but what it's doing is it's stretching. I got a question. Think of it vertically, you're stretching it out. Horizontally, is it getting skinnier or fatter? Imagine you're stretching a gummy bear in your hands. You think it's fatter? No. I would say that these gummy bears get really skinny when you stretch them vertically, right? All right. That's what's going to happen to this parabola. This parabola, I have for you graphed just regular x squared. I want to show you what 2x squared is going to do. What it's going to do is it's going to stretch this parabola vertically. The effect that you might see is you might say, hey, it's just making it skinnier. And I would say, no, it's not necessarily that it's skinnier. Yes, it is skinnier, but I think of it more as I'm stretching it vertically. Let me show you what the graph looks like, all right? All right, you guys see this? It's like I took the red graph and I grabbed him by the feet right here, and I grabbed the top over here, and I pulled him up. And no, don't torture me! So that's what I'm doing. Does that make sense? So it's kind of making the parabola a little bit skinnier, But really, it's making it like vertically taller. That's the way I think of it. And when I look at this, I think of gummy bears. Because for some sadistic reason, all of us eat gummy bears like that. Or at least you should. If I put a bigger number there, what do you think will happen? If I put, instead of a 2, what if I put a 4? What will happen? It gets really skinny. All right, let's try it. I agree. If I put a 10, it gets even skinnier. If I put a 100, it gets incredibly skinny. Are we cool? All right. So all I really want you to know is that the number out in front over here changes the, if it's a positive number, well, it doesn't matter if it's a positive number. If it's a number bigger than 1, because right now I'm assuming that there's a number 1 out in front there, but if it's a number bigger than 1, then it gets skinnier. Like 1.5. 1.5 is technically bigger than 1, it will get skinnier. And I don't really want you guys to think about it getting skinnier. What I'd rather you guys think of it as getting vertically taller. Cool? Now, here's my other question. What is the other way to eat gummy bears? And I know you do this too. I do it. You don't stretch them out. What I do is I hold the gummy bear in between my fingers, right? And I squeeze it down. And I squish them, and I'm like, no, you're going to die. And then I pop them into my mouth, right? Mr. Dalday is very creepy like that. That's the way I roll. It's actually not the way I roll. I don't like killing things or anything. But they're gummy bears. They're dead. I don't mind. All right. I guess to me that's a lead in to say, well, what happens if I put a 1/2 out in front? Well, that's what's going to happen. Is these gummy bears, this parabola, is going to be squished down vertically. Now, as you squish these things, imagine squishing the gummy bears in your fingers. What happens to them? Are they going to get skinnier or fatter? Yeah, exactly. They're going to go on the cheeseburger diet. Right? They're going to just get fatter, right? So let's try it. Oh, oops. There we go. You see, this the red parabola is there for comparison, but the blue parabola is the one that we're most interested in. If there's a 1/2 number out in front of it, it's going to get fatter. Are we cool? But again, I don't really want you guys to think of it as getting fatter. I'd much rather you guys think of it as getting vertically compressed. I don't know. Maybe that might be the more politically correct way of saying it. Okay, let's do this. All right. All right. I'll tell you what. Let's play this game. This is actually kind of fun for me. I don't know about you, but it's fun for me. Okay. What if I did this? What if I said -5 and I put a -2 over here? What would this graph look like? Oh, come on. You guys can do this. You can do this. All right, here, let's ask this question slowly. Okay. What would the -5 do? What would the -5 do? Rainy, you're close. It's not exactly right, but I like that you're guessing. Let me ask you this. What would the negative 5 do? Bring it down. Yes, exactly. By how much? Very good. Awesome. Okay. What would the negative in front of the x squared term do? This thing right here. It makes it fatter. No, it doesn't. Nope, it doesn't make it fatter. Flips it upside down. There we go. Awesome. It flips it upside down. Okay? Now let's talk about this. What would the 2 do? I'll tell you what, Justin, why don't we take a look at that? Remember if I graph negative x squared? If I compare that to my parent function, which I call the parent function, it just means the regular function. It's the orange graph is really just the red graph, just flipped upside down. You see that? Okay. So I'm arguing with you that this negative 2 will flip my graph upside down. Now, what would the 2 do? The actual 2 in front? I'll give you a hint. It would make it. All right, I've got people saying make it skinny. It would make it fat. Why don't we take a look at what this graph actually does look like, and we'll see who's right. All right, there's my graph. Is it skinnier or fatter than the one on the bottom? Or the right one? It's skinnier. It might not be obvious, but I mean it's a little skinnier. Like, for example, if I just had negative x squared, what's going on? Is caps lock on? What's going on? Negative. Oh, the caps lock is on. I can't turn it off. I don't know what the deal is. What's going on? Let's see. Wait, is num lock on? Num function. Oh, my computer. My computer. Ah, what is going on? Ah, man, every single thing that doesn't want to work didn't work today. Arrgh. Yeah, it's like the L button doesn't work. The caps lock is stuck on. The number lock is on. What just happened? I didn't touch anything. Scroll lock off. Like the computer just decided to go all funky. Hello. Why is the caps lock on? Yeah, look, watch. This says caps lock off, right? Hello. This is weird. But then if you look at the bottom right hand side again, caps lock is on. Hello. This is the opposite day. Yeah, right. Yeah, if it were a Mac, my Mac wasn't working before. I don't know. Whatever. Does it work now? Okay, you know what? I'm going to close Desmos. x squared at what? X squared. Oh, you know what? I bet you I know what it is. Ah, I know what it is. The shift button was stuck. Anyway. X squared minus. Alright. So anyway, what I'm saying to you is I'm graphing the negative 2x squared minus 5. And if I were to graph maybe negative x squared minus 5. See, this graph, the green graph right here, would be without having the 2. And if you can compare the green graph to the blue graph, you can see that that 2 made it skinnier. Do you guys see what I'm getting at here? Alright. So the shift button on my computer is a little bit funky. It's alright, I can deal with that. Alright. So, what if I did this? What if I made it negative x squared at squared plus 4. Should I go negative x squared? No, I'll just go like this. 1/3 x squared plus 4. What would that graph look like? 1/3 x squared plus 4. All right, let's take it slowly here. What would the 1/3 or what would the 4 do? If you guys can get a good feel for this, then you guys will be pretty set. The 4 would make it. It would go up by 4 and it would make it fatter. Actually, Kiana, you got it exactly. Let's take a look at what the graph actually does look like. There we go. See, all it is it's the regular parabola pushed up by 4 units and made fatter. Are we cool? So I'll tell you what we'll do is, since I'm such a nice guy, and I really am such a nice guy, or at least I think I'm a nice guy, why don't we take a look at some of your homework for you? Alright. Yeah, I'm not nice to gummy bears. Yeah, that's true. That is true. Tell you what, let's take a look at what your homework's all about, and then maybe we can see what we need to do to submit it. Oh, okay, here we go. Find the symbolic representation of the blue graph. Okay. Here's what I'm going to say, all right? Here's what I'm going to say. What are your thoughts? I'm going to ask you. All right. If I have a number A and C, and that's what I want to figure out. What is A and what is C? To make the red graph into the blue graph. Do you think we're going to have a number for C? Do you guys understand what I'm saying here? No. Yes. You're absolutely right. We're not going to have a number for C. The reason being is because that number for C, this number added over here, that will move my parabola up or down. Right? But the blue graph is exactly at the same height as the red graph, so I don't want to move this parabola up or down. So I can tell you right now that the answer for C is going to be 0. Does that make sense? Now, the number for A, this number out in front, this can do 3 different things, all right? It can make it skinnier, and that would be if the number was a number bigger than 1. It can make it fatter, and that would be if the number over here is a fraction that is smaller than 1. Or this A can also flip that thing upside down, and that would be in a case where this thing would be negative. Now here's my question to you. What is your guess as to Is it a which one is it? Is it negative? Is it positive? Is it a number bigger than 1? Is it a number smaller than 1? What's your thoughts? It's going to be a positive number that is more than 1. I'll tell you what, why don't we graph that and we'll check to see if that might be close. So, let's see. All right. Kiana says it's bigger than 1. I'm going to try 3. All right. My blue graph actually looks smaller than the red graph, and that's not what I want. So Kiana's saying, no, oops, I mean smaller than 1. All right, let's try 1/2. Okay? All right. Now, here's what I would do. All right? You guys have basically got the idea for this thing. And you're absolutely right. I think that A is going to be a fraction, and I think C is going to be 0. Just by looking at this graph, I can kind of tell properties of this graph. That's the strength that I want you guys to have. That's the key to all of this. All right. So I want you to watch all the all of the watch videos, but this is what I really want you to understand how to do. We cool? Now, here's the thing. Is the A going to be 1/3, or is it going to be 1/2, or is it going to be 1/4? Because we know it's going to be a fraction that's bigger than 0 but smaller than 1. All right? But it's hard for me to tell if it's going to be a fraction that's 1/3 or 1/2 or 1/16 or whatever. You guys see? Now, I can show you exactly how to tell this graph. I'll show you the trick. You guys ready? I would make a little table. And it doesn't even need to be a big table. It can be a little table. I would choose a point on this graph that you can actually see very well. I would say that x equals 3, y equals 3 is a very nice number to be able to see very well. Would you guys agree? That is a number that lands on this point very nicely. I would say that's the only number you can read very nicely. X equals 3, y equals 3. Okay? So what I would do, if I were you, is I would test things out. I would say, my graph, I think, and by the way, this is just our work over here. I would guess that my graph looks like 1/2 x squared. That's what my guess is, okay? Let's plug, and this is y equals 1/2 x squared. Cool? Let's plug in our guess and see if we get the right answer. We should get such that x equals 3 and y equals 3. So if I plug in 3 into here for x, I'll have 1/2 times 3 squared, which is 9. Is this true? Is half of 9 equal to 3? Hello? No, obviously not, right? Okay, all right. So that's wrong. So let's take another guess. What if we try 1/3 x squared? Okay? If I plug x into here and y into here, is it going to give me a true statement? 3 is equal to 1/3 of 9. Is that true? Good. Then that's my answer. That's me being able to find the graph of this thing. I would type in 1/3. Whenever I'm asking you put in something like this, I don't want you to put in the decimal, and I want you to use a fraction instead, and I don't want you to use any spaces. If it's a negative out in front, then put the negative, but never use any spaces and always use a fraction. If I were to take a look at exactly what I have for this quiz for the answer, I said that the answer is, yeah, A is 1/3 and C is supposed to be 0. Exactly. Good. So we know we got it right. Do you guys understand how to do this? And look, I did the first problem on your homework for you. All right, let's take a look at this one. I mean, I think that this might be a good thing for us to talk about. What is your thoughts about this graph right here? What is C going to be? C is going to be 1. Exactly. Very good. Because you're moving the graph up by 1 unit. Yes, I completely agree with you. I got a question just from your instinct. Do you think A is going to be a positive number, a negative number? Is it going to be a number bigger than 1 or a number smaller than 1? Okay, we've established that it's going to be positive. I agree with you as well, because if it's negative, it's going to be upside down. And it's going to be bigger than 1. Why would you say it's bigger than 1? Because it's skinny. Exactly. There we go. Now, I would choose a point where this graph lands nicely. The blue graph, that is. And I would say that maybe at x equals 1, y equals 3 might be a good point. So I would guess as to what my graph might look like. I would say, why don't we just try y equals x squared plus 1. Oh, I'm sorry, 2x squared plus 1, because I'm thinking that it's going to be skinnier, right? So that's why the 2 is out there, and the plus 1. I know that the plus 1 is correct. What I'm wondering is the 2 correct? I can read a good point off my graph as x equals 1, y equals 3. So I'm going to plug that into here and see if that ends up being a true statement. If I plug in 1 in for x over here and 3 in for y over here, that would say that 3 is equal to 2 times 1 squared. 2 times 1 squared is just 1. So 2 times 1 is 2. Plus 1. Is 3 equal to 2 plus 1? Yes, obviously. Yes, duh. So, I think that that's the correct answer. And let's see what I told the computer to grade as the correct answer. A is 2, C is 1. Yep. See? A is 2. A is the coefficient in front of the x squared term, and C is the coefficient that doesn't have an x next to it. So remember, what I'm looking for when you guys plug this in is I'm only looking for the numbers. I only want you to write down 2 and the number 1. Because what I'm doing is I'm already implying that I'm taking into account the x squared already. So A is not 2x or 2x squared. A is the number 2, and then you have the x squared. It's built into x squared. Does this make sense to you? Alright. I think this game is pretty straightforward to play, to be honest with you. Let's take a look at this one real quick. What would you say? Tell me what your thoughts are. And then, you know what? Actually, you know what? I hate to say this, but I got to finish now because A, I got to go bathroom. I got to pee. And B, class got to finish in 2 minutes so I can get started on my next class. So I'll talk to you guys later. I've been drinking water like nobody's business because I've been kind of sick. So I really got to pee. I'll talk to you guys later. See ya.